Hey guys, this is a lesson on quantum numbers. Quantum numbers are built on electron configuration and orbital filling diagrams. So let me just do the electron configuration for beryllium. Beryllium has an electron configuration of 1s2, 2s2, okay, because it has an atomic number of 4. The energy diagram for that would look something like this. 2 boxes, 2 arrows in each box. Okay, now for quantum numbers, you have to be looking at one individual electron. I liken this to an electron configuration is like an entire apartment complex, okay? We know where all of the tenants are. Quantum numbers, we care about one individual tenant, okay? We have a set of 4 quantum numbers that tell us exactly where one electron is, where one tenant within that apartment complex is, okay? So I'm going to be referencing this example, and whenever I reference this example, I'm going to be talking about just this bolded electron, the one that I drew darker than the others, okay? So let's talk about what the 4 quantum numbers are. For each electron, it has a set of 4 quantum numbers, and they start out as N, and they go to S, and they become more and more specific as we go, okay? So N is the most general quantum number, and it's the principal quantum number, and what it really means is energy level. N for energy level. Okay, so in our example here, that bolded electron, that 2 in front tells us that it's on the 2nd energy level, so N equals 2, okay? And N can have values of any whole number 1 through 7, because there are 7 different possible energy levels. Is it possible that we could eventually have a number greater than 7? Yes, but we don't have any elements that have been created yet. And I say created because at that size, there are no naturally occurring elements. It is possible we could create an element with an 8th energy level, but it hasn't happened yet. If we make any atoms any bigger than the ones we have currently, it will be an 8th energy level electron containing atom, okay, which is pretty cool. Anyway, so energy level is symbolized by quantum number N. Okay, that's the most general. And think of that as like it relates to, you know, on Bohr models, we had those different circles, right? And the first one could contain, 2 electrons, and the second one could contain 8. Those energy levels are what we're talking about here. So obviously it's pretty broad. Multiple electrons could be on the same energy level. So we're going to get more specific. So L, and then the second one contains 18, and you know the drill, right? Okay, so anyway, back to L. L is angular momentum, and what that means, essentially, is which sublevel an electron is located in. So, for example, an S sublevel has an L value of 0. A P sublevel has an L value of 1. D sublevel, L value of 2. F, you guessed it, L value of 3, okay? So back to our example here. Since our bolded electron is in an S sublevel, L equals 0, okay? All right, again, this is getting more and more specific. However, 2 electrons could exist within this sublevel. We'll continue on. Okay, M is magnetic quantum number, and what it means is which orbital an electron is in, okay? And so what I mean by that, and if you look at your quantum numbers cheat sheet, this kind of follows that same idea. Magnetic quantum number works a lot like a number line. So you know how on a number line, the middle point is 0, and then the first value to the right is 1, and the first value to the left is -1, and the further out you go, the more negative and positive they get. M is just like that, only we look at the sublevels. So for, like, let's say a P sublevel that has 3 orbitals in it, the middle one is 0, and like a number line, the left one is -1, the right one is +1. So in the same thing would be true if you had a D sublevel or an F sublevel. The middle orbital is 0, and then you number out from there. Now, in an S sublevel, as we have here, all we have is a middle box because S sublevels only have 1 orbital. So for that reason, M equals 0. okay? Now, S is all about spin. So, if an arrow is pointing up, S equals positive 1/2. If the arrow is pointing down, S equals negative 1/2. So, in this case, with our arrow pointing down, S equals negative 1/2. So you can see, as we went on, it got more and more specific. N told us it was on that second energy level, okay? L told us it is in an S sublevel. Of course, we know S means a sphere, okay? M being 0 means it's in that middle orbital, okay? For S, there's only a middle orbital. And then for our spin, it says it's negative 1/2. Okay, not only is it on the second energy level in an S sublevel, in that orbital, it is pointing down. So you see how as we went, it got more and more specific. So while you were looking at that, you should have been looking at your quantum numbers cheat sheet. So this kind of just goes through and gives you more information about those same things. On the back of your cheat sheet, there are practice problems. Okay, I want you to do those practice problems. Most of you already have, only if you were absent a couple of days have you not completed this. You have several different worksheets that have the same kind of information on it. I'm going to do one of these just to kind of hammer home this idea. So let's do 11B. So N we know is the energy level. Well, this says it's a 5s electron, so that means it's on the 5th shell, or the 5th energy level, so N equals 5. L we know is all about sublevel. This says it is an S, so L equals, you guessed it, 0, okay? Since it is an S, there is only a middle, like think about your number line, there's only a middle orbital, so M equals 0. And then for our spin, that electron is pointing down, the arrow is pointing down, so it's negative 1/2. Okay, let's do just one more here. We're going to do D as well. So this says it is a 3D orbital, and the electron that we care about is here in this middle box. N, energy level, that's the coefficient in front, okay? L, this is a D sublevel, and remember S was 0, P was 1, D, there we go, D is 2. So L equals 2, because it's a D sublevel. M, remember that's the one that's like the number line, okay? So 0, 1, 2, negative 1, negative 2, okay? So that was in the middle box, M equals 0, and then spin, positive 1/2, because our arrow's pointing up. I hope this video was helpful for you to understand quantum numbers. Please let me know if there's anything else I can do.